Alright, so this is review video number 3. The first video was 1, 4, and 7. The second period video was 2, 5, and 8. This is now 5th period. I'll do 3, 6, and 9. So go find the other videos if you're looking for one of the other problems. Alright, number 3. If x squared y minus 3y squared equals 5, find the slope of the tangent line at 2, 1. So slope of the tangent line, that means derivative, that means dy dx. So let's find the derivative of this thing. In fact, let's get some help to find the derivative of that thing. Grace, you get to start us off. But it's a kind of a big question to ask you to find the derivative of that first thing. Don't just read. What rule am I going to use to find the derivative of x squared y? Product rule. So do you want to do it, or do you want me to pass it off to somebody else?
I feel like I'll regret saying it.
But you're going to go for it. I like that. So first times derivative of second. I'll walk you through it.
And then can you do the y now?
Yes. Okay, so be careful. You're doing it derivative of first times the second.
Oh, wait.
That's okay.
It's just y.
Yes.
Okay.
Plus, now you need to do the other way around.
Square. And then dy dx.
Good.
Okay, I think I'm going to stop there, actually.
No, that's fine. You did more than expected. Wait, shouldn't have phrased it that way. I didn't mean more than I expected. More than I expected you to offer to do. You went above and beyond what I was trying to say. Not that you went more than you were capable of. Austin, how about, save me here, how about the derivative of 3y squared? Dy dx. And so that's the big problem, is forgetting the dy dx. Ben, how about the derivative of, make sure this is really Ben's popsicle stick, the derivative of 5? 0. So let's factor out the dy dx. That leaves x squared minus 6y. I'm going to move the 2xy to the other side. So dy dx is negative 2xy over x squared minus 6y. And if you look at problems 1 and 2, that's basically where they stop. But this one gives you a point to plug in. So if we evaluate that at 2, 1, the bar that means evaluate at 2, 1, negative 2 times 1 over 4 minus 6. Let's see, so that's negative 4 over negative 2, which is 2. I mean, this was a safe stop, but it was multiple choice, so it wasn't really an option. Number 6. If x squared plus y squared equals 25, what is the second derivative at 4, 3? Well, I don't do a second derivative until I do a first derivative, so let's take a derivative with respect to x. And we'll even pick on some people. Pick on 3 people. So, Braden, what's the derivative with respect to x of x squared? 2x. Ethan, what's the derivative of y squared with respect to x? 2y. Good. And then Lucas, what's the derivative of 25? 0. Okay, so dy dx then, the first derivative is, do a couple of algebra steps, negative x over y. But I'm only halfway done, right? Like I want the second derivative. So I'm going to call the top f and the bottom g to do the product rule. Oh, let's just keep pulling popsicle sticks here. Thomas, if f is negative x, what's the derivative of that? Negative 1. I do need to be careful about the negative. I could have just left the negative out front and then stuck it on at the end. I'm going to attach it to f, and that way I'll carry it through. I don't know which way is easier. Victor, how about the derivative of y? dy dx. Okay, so the second derivative then, using the quotient rule, gf prime, the gf has to come first. So that's negative y minus negative x times dy dx all over y squared. I can clean that up a little bit, I guess. Negative y plus x dy dx over y squared. The formula is gf prime, right? The gf has to come first, minus fg prime over g squared. Previously, when we were working with this, we had to take that negative x over y and plug it in for dy dx. But I don't think I have to do that on this one. I can just plug in 4, 3 in the places and go from there. Although I will need dy dx at 4, 3. That would just be negative 4/3. So, negative 3 plus x is 4. Dy dx is negative 4/3 all over y squared. So naturally that doesn't work well. Let's multiply everybody by 3 over 3 to clear that denominator out. So that would be negative 9 minus 16 over 27. So negative 25 over 27, and that is answer choice A. There's a bit of a check on this problem. Do you know what x squared plus y squared equals 25? Do you know what shape that makes? A circle. Assume that's a circle. At the point 4, 3, that'd be over here somewhere. First derivative is slope, so I would believe that my first derivative is negative 4/3. That's fine. I don't think we've talked about what the second derivative tells us yet. So maybe there's not enough to check. It tells us it's concavity. That's concave down, so it's negative. Number 9. I feel like number 9 is the hardest of the problems that we work because it's got an R and an H and they're both changing. So I need to worry about there being a dr dt and a dh dt. And I'd really rather not worry about both of them, so maybe there's a way around that. A container has the shape of an open right circular cone. Got it? In the figure on the right. Radius of 4, height of 12. So already I'm thinking ahead. That means h is 3 times r. or R is H over 3. I'll probably need one of those. Water flows into the container at a constant rate of 6 cubic feet per minute. So in terms of the variables in this problem, what is 6 feet cubed per minute? What's it telling me there? That's how the volume is changing, so that's dV dt. How fast is the water level rising? So what's it asking me to find? Yeah, be careful, not just the height, but how is it changing? So dH dt when h is 5. Now, my formula has h and r in it. I'd really like to make one of them go away. Based on what I know and what I'm trying to find, which one would I like to make go away? The r, right? I've got h stuff, so I don't really want r in my problem. So let's replace r with h over 3. So v equals pi over 9 times 3 is 27, h cubed. Still really haven't done any calculus. I've been doing algebra to make my calculus easier. dV dt then is 3 over 27 is 1/9 h squared. And if I stop there, I bet that's a multiple choice answer of whatever that is, h 25 pi over 9. But that's not right. What have I gotten wrong here?
Plug in 5.
Okay, so if I plug in 5 for h, I get 25 pi over 9.
We used to put dH dt.
The dH dt. Alright, so dV dt is 6 pi over 9 times 5 squared dH dt. Is that a safe stop?
No, because the DHT needs to be bytes.
Right, I need to solve for dH dt. It's got to be calculator ready. That's not calculator ready just yet. Close. So I'm going to multiply by 9 and then divide by 25 pi. And that is a safe stop. It didn't ask for units, but feet is h, time is minutes, so feet per minute.